All right. Hello, everyone. Good morning, good afternoon, good evening, wherever you're tuning in from. Thanks so much for joining us here today. We're super excited to show you how Oracle Database 23 AI makes AI simple and powerful with vector search, RAG, natural language, and more, with lots of demos lined up for today. So on the next slide, and if you have any questions for us, we do have experts from the Oracle team here in the chat, so please do ask us throughout the session, and we'll have some extra time at the end to answer anything live that hasn't been addressed yet. So please do let us know all your questions. And then on the next slide, I'm pleased to introduce our speaker for today, Stacey. He's an Oracle Database AI product manager. So without further ado, please take it away, Sean.
Thank you, Tara, and thank you everyone for attending. I am going to switch decks really quickly. Can you see my screen okay?
Looks great.
Perfect. And I'd also like to mention my colleague, Marcus Kissling, is on the line as well, and he's going to be supporting me with helping with Q&A and chat. So thank you everyone for taking the time out to attend this session today. Hopefully I will keep it exciting and interesting, and it will keep you enthused. One quick comment before I get started. I do want to mention that this is going to be completely interactive. I'm going to be jumping, well, actually, let's pull up the agenda. I'll give you a quick introduction of what we're introducing in Oracle Database 23 AI, specifically around AI functionality. And all these numbers here equate to demonstration. So I'll give you a little bit of an explanation of what the technology or the feature is and how it works. And then I will give you a live demo. But before I do that, I'm actually going to minimize my screen again, and I want to show you something here. And it is, whoops, wrong screen. I've hit the wrong button there to maximize my screen. Come back. Oh, come back. There we go. All right, so I wanted to show you all this. And I do have the URL at the end of my presentation. But just be aware that Oracle does offer certification for various flavors. And right now, we're running a program with a race to certification where you can get certified for free on any number of topics. And specifically around AI, we've got our AI vector search, OCI data science, and our AI foundations. So some really good stuff there. Generative AI is as it relates to large language models. So definitely keep that in mind. If this is something you would like to know more about and become more of an expert, definitely consider taking those exams. And I do have a slide at the end of my presentation that includes a link so that you don't have to remember any of these URLs. Also, all the demonstrations I'll be showing today, I've posted on a GitHub repo, and there are links in my slides as well. So you'll be able to access the code yourself to take home and play with and change. So moving on with our topic, really quickly, Database 23 AI introduces a ton of AI functionality, with the core one being our AI vector search feature. And what I want to say about AI vector search, and I'll explain it as we go along, but in essence, what we've done with this feature is we've enabled the Oracle database to become a vector database. So we can run any vector workload you would run on a single store vector style database. The Oracle database now is able to run those workloads very efficiently and effectively. The other thing I really want to emphasize is all of the functionality I'll be talking about and everything that you see on the screen right here in terms of the functionality we've rolled into Database 23 AI is available with no additional installation. It's already pre-installed, it's already pre-configured, and there's no extra cost associated with using any of these services within the Oracle database, right? Unless you're using some commercial large language model or some other component that may have a cost associated with that particular vendor. But in terms of all the functionality I'll be talking about and all the features we support within the Oracle database, it's all already pre-installed and configured, and it's available in the Oracle database for no additional licensing costs. And on top of that, whether you're running on an Exadata in the cloud or on premises, or you're running in an Oracle Autonomous database, or best of all, if you're running a developer free release on premises on your laptop, this functionality is there and supported. So there's no barriers, hopefully, to prevent you from developing with Database 23 AI today. So a real quick primer for those of you who may not be familiar with what a vector database is or what vector search is.
Sorry to interrupt you. We lost your screen share.
Oh gosh, okay. I apologize for that. This happened the other day, and I'm not sure, and this may happen again then. So bear with me if that does happen again. And now I've got to find my Chrome browser. Sorry about that. Entire screen share. Do you see my screen now? And let me kill Zoom.
There you go. It's pulling
Okay,
up.
so closing it. Do you see my? Yep, I see my screen is presented correct.
Yes.
Perfect.
There you go.
And this did happen the other day when I was using a Teams meeting. So if it blocks out again, just let me know. I apologize for that. So just really quickly, what vectors are. So vectors are a new technology that allow you to take a digital object, whether it's a image, whether it's a video, whether it's a document, and to be able to search upon, semantically search against those objects. And in this simple example, we've got a video of a mountain, we've got a photo of a mountain, we have a document that happens to mention mountains, it could be an audio file. We're able to search for the term mountain, and all three of these types of objects would be displayed, right, in a multimodal manner. And the technology that enables this is something called a vector. And a vector in computer science terms is nothing more than an array of numbers or a series of numbers. And these numbers are called dimensions. And the dimensions capture important information about what's in this digital object or this image or this audio file, etc. And these vectors are created using embedding models. Some of them are neural networks, some of them are transformers. There's different techniques to creating these vectors. But once you have something vectorized, once you've taken this object, this digital object, this file, and created a vector for it, we can now perform mathematical distance calculations, right? And there's a ton of them that we support out of the box, from Euclidean squared to Manhattan to Hamming to Jacquard to cosine to dot product, and the list goes on. We even allow you to create your own custom distance formulas. But basically, once you've got this vector with this series of dimensions in it, it's possible to perform distance calculations to determine the similarity between different objects. And one last slide before I get into explaining and showing you this stuff at work, to explain a little bit more about what a vector is. In this simple example, we've got a vector that represents this photograph, and this photograph happens to be a hiker on a hiking trail. And you'll notice the dimensions 33, 42, 16. In this simple example, this two-dimensional example, the dimensions talk about some semantic content in that image, right? So there's a Douglas fir tree, there's a bridge, a river, there's a hiker, etc. It's not saying that 33 says that pixel or X43 by Y76 is green or brown or gray. It's saying that this is the type of object that's presented in this or represented in this digital object. And once we have that information, in a sense, the vector is more important than the image itself, because we have some contextual understanding about what's in that object, right? So with that being said, let's have a look at how we can, well, before I do that, you know what, I have a demo that I was going to jump to called AI Vector Search in Action, but I'll show you a Python version of creating vectors and actually querying a table with some vectors in it. So let's jump to my command prompt. Hopefully, do you see my window okay? I'll make my font larger. Great. So I am going to run a Python program called create schema. And this Python program has just gone into an Oracle database, and it's created a table called my data. And if I connect to my Oracle database, I'm going to connect as vector at PDB1. This is a free database I'm using. And I can describe the, oops, I think I just lost sharing. So let me just bring that back. Okay, I'm sharing again, so bear with me. While I'm waiting for that to reappear, I can start typing. Let me know if you can see my screen okay. Nope, I'm guessing that means you cannot. Do you see my screen now?
Yes.
Perfect. So I've created a table called My Data, and it has these 3 columns in it. And if I do a select star from my data, order by 1, we'll see there's a bunch of rows in there. There's actually 150 rows in there, and they're just random factoids, right? Like information, Denver, Colorado, had some stuff about cars, etc. Once I've done that, I can now go ahead and vectorize my information, and that's where I run an embedding model against it. So now I'm going to run Python 3, and I'm going to call it vectorize, and I'm going to use sentence transformers, which is a free embedding model from Hugging Face, and I'm going ahead and vectorizing that data. So basically, I'm taking every row in that table, every factoid, and I'm creating an embedding or a vector for each one of these entries, right? And I happen to be using an embedding model here. You'll notice at the very end of it that says I'm using multilingual. So I've used a multilingual embedding model. So now I can go ahead, now that I've done that, and I can actually perform a similarity search using those vectors that were created. And I'll show you more about what they look like in a moment, but an idea of the type of things we can perform when we have these created. So I'm using the sentence transformers again, and I'm going to use that multilingual E5 large embedding model, and I'll explain a bit more about that in a moment. So let's enter a term. I'm going to say cars, and it's going to find me entries. Now, this is important to understand. With similarity search and with vector search, the word car is not in any one of these entries, right? Ferraris are often read. We as humans know that a Ferrari is a car, a Tesla is a car, an Alfa Romeo is a car, right? So similarity search gives you that power, and that's what we're bringing to the table here. Now, I mentioned I'm using a multilingual embedding model, so I can actually say, hey, what's the word in Spanish? Well, coche, and I've got the same answer. I could say voiture for French, French for car, and I've got an answer as well. So the power of similarity search and vectors hopefully is apparent to you. So I'm going to quit that, and I'm going to run back to my demo sequence just to give you an idea of how this works, and that's a Python program that I'm doing this with. Let's have a look at how we would do it in Oracle. So for my first demo, I'm going to use something called Onyx. So the Oracle database, and by the way, I'm running in an autonomous database 23 AI instance, and just to make sure I'm connected, yep, I'm there. The autonomous database always free is supported, so it doesn't cost anything to sign up for an always free account of the autonomous database, and that's what I'm using for this demo. I'm going ahead and I'm creating a credential in my database, and this is just so I can access a bucket. So I'm going to access an object storage bucket. It could be an S3, it could be an AWS S3 or an Azure Blob or whatever, but I'm using Oracle, obviously. I'm going to point to an Oracle object storage bucket. And I'm just going to verify that my credentials are there to access my bucket. And here you can see the one I'm using here is my OCI bucket credential. You may also notice I've got an OpenAI credential, and I'll talk about that in a moment. I can list the contents of my bucket by running this particular SQL statement here, and it will list any files that I've loaded. Now, I've blurred that out, or I've modified that just to give you an idea. When you download these scripts and play at home, you know what you need to enter there to make this work. And then I can go ahead and load my model. And in this case, I've got a model I've called All Mini LML12 V2 Onyx, which is an Onyx compiled version of the All Mini LML12 sentence transformer model that I've grabbed from Hugging Face. So a quick one for those of you who may not be familiar with it. The Onyx runtime is the Open Neural Network Exchange, and it's a way of providing embeddings and running them inside the Oracle database. The Oracle database has an Onyx runtime that we support models. So in this case, I'm going to run this inside the Oracle database, which gives you the added benefit of the security of being able to run a workload within the security of my Oracle database and never having to leave my database once that model's been loaded. Now, if I was running this on my own machine, like I showed you in my shell example, I could point to a directory, and that directory is where I would load that model. So that's another way of doing it. Once I've got my model loaded, you can see I've got several here that, or four that I've loaded. I've got the all mini that I've loaded. I've got some clip vit, which I'll show you how that works in a moment. And I've also got that multi-lingual model as well. So I'm going to use a factoids table, which should look familiar to you. It's my entries that I showed in my data table that I showed you earlier with these various entries. There's the ones with the cars, right? So once I've got these entries, I'm actually going to go ahead and I'm creating a new version of my data table that I just showed you. So I'm dropping it. I'm going to recreate it. And in this case, I'm going to embed the data from within the Oracle database using this vector embedding package. So I'm doing this function call, and I'm going to convert my column as a vector from my factoids table. So I'm taking that factoid, that piece of information. Oops, and I lost my screen again. I just saw that happen. Wow, this is really annoying. Bear with me. Hopefully it will reappear in a moment. But in essence, what I've done is I've taken those factoids, for example, oh gosh, I'm sharing my screen again. Hopefully this works this time. I'm not sure why I'm having these problems. It could be my network. But in any event, I thank you, Nishant. So I've taken those factoids, for example, Ferraris are red or Porsches are fast or Teslas are electric. And I'm taking those factoids and I'm vectorizing them and storing them as such in my data table. So now when I look at my data table, I must have lost my connection. Let's run this again. Oh, I'm not having, okay, so I created the table. And now when I query my table and look at it, you can see here's my strings of information. For example, Alfa Romeo is a fund, and here's a vector for you. Here's what it looks like. And I can scroll over. The embedding model I'm using has 384 dimensions, this vector, and it's float through. And that's what I'm using for mapping these strings of information. Once I've got that there, I can perform a similarity search. And this is really simple. I'm going to build upon this demo in a moment. But in this case, I'm going to run a query. So let's go ahead and run one. We used cars before. Let's try that again. So here we go. Here's our entries. I can try it again. And I can try New Zealand, because I know there's some entries to do with New Zealand. And this is an interesting one. I always like to point this out. So Wellington's the capital of New Zealand, legitimate. Kiwis taste good, yeah, that's New Zealand. There are no snakes in New Zealand. All of these look legitimate, right? And Sydney is in Australia. One could argue, well, it's the Southern Hemisphere. It's a city that's very close to New Zealand. So I could see how it came up with that one. This one kind of is a bit of a head scratcher, right? We have Staten Island is New York. If you know anything about the history of New Zealand, it was originally called New Staten Land, which I guess that's how this has come up with that correlation. So just a bit of a caveat there. This is based on embedding models that sometimes will influence your results. And this is not a hallucination. It's actually a correct result, but it's something you do want to be aware of. So I'm going to jump back to my presentation because I've got some other things to build upon. And the next topic I want to talk about is, so I've shown you how to load those embedding models. And by the way, here's where you can get that script. It's available in my GitHub repo. As I mentioned, we will share this deck with you, and I have a link to all of everything I'll be showing you. So the next thing I want to show you is another demo that I created called nationalparks.sql. And the reason I'm showing you this one is it's going to take what we're doing with embedding models and show you even more power. So we've seen embedding models with sentence transformers, basic all mini LML12, as well as the multilingual. Let's have a look at some multimodal embedding models, and in particular, the clickbit embedding model. So with that one, I've got a demo that I've created called National Parks. And for this one, I'm actually going in, I've loaded my model, but this time I'm actually pointing to an external location, and this is a website. So what I'm doing here is I'm taking a table of information that's publicly available from the National Parks repository, the American National Parks. And Suresh, yes, I'll definitely be sharing those links, and I'll share them again. But we've taken, it's not just myself, a group of us, Marcus included, have taken these objects, loaded them into our Oracle database, and we've created embeddings on both the images as well as descriptions of the national parks. And we're using that as the basis of our queries. So in this case, I'm actually showing you how I'm going to map my directory where I'm loading my models for. So I mentioned before, right, that we could use either an object storage bucket to map our embedding models. In this case, I'm using a directory called vecdump on my local server. And I'm using these three models. I'm going to use all three of these. I can drop them, but this is what I would have used to have loaded them. So I'll show you the process of loading one. So I'll drop this one first. And then I'll go ahead and reload it just so you can see the process and how long it takes. Now, the bigger the embedding model, some of the more sophisticated embedding models will take longer to load. You can see this one happened fairly quickly, right? And loading a ClipVit-based Patch 32 Onyx model is no different, right? The process is identical. Now, one thing we've done, we're providing these embedding models for you to use. You can take your own, and we have documentation in the Oracle documentation set to take your own proprietary embedding models and load them into the Oracle database if you wish to use that. And by the way, that Python version that I ran, I didn't run that within the database. I ran that against Hugging Face that was sitting in a third-party location. So you don't have to load the models into the database. I'm just showing you how you would do it if you want to run it in the database. Once I've loaded my models, once again, I can verify that they're indeed running inside my database, and I can find out more information about it. And if you're interested, I can run a string, right? So I can say, hey, select vector embedding using my all mini LML12 Hugging Face sentence transformer model. Say, hello, AI camp. Oops. And I'll run that for you, and you can see what a vector for that looks like. And here you go. It's just a string of numbers. If I use this version, it might be easier to look at. Yeah, there we see. Now there's 384 dimensions in the all mini LML12. So there's a ton of these numbers to look at, right? So in this case, I am going to use a table called park vector. To save time, I'm not going to run this. It's already been populated. I've already got my descriptions, vectors generated for the descriptions. And now that I have that information there, I can actually run a query against it. Perhaps I want to canoe, run a query, and it's going to show me the national parks and the vectors that map to that term that I've entered. And here I can show you what it looks like when I, oops, bear with me. Hopefully my screen will reappear in a moment. Okay, there we go. So this time I'm going to run the query again, and I'm going to show you a row in the table using that vector similarity search. So when I run that, oh gosh, I keep losing my connection today. The internet gods do not like me or something. Bear with me. There it goes. So this time I'm running my query, and I'm going to use canoe again. But instead of running it with just a vector, I'm actually going to pull back a row in the table. So when I run that, you'll see here's the 10 closest rows. So I'm using order by distance. So I'm looking for the 10 closest using that vector similarity or that vector distance metric, which I'm using cosine here to perform that query. I'm able to grab those first 10 rows only. And you'll notice if you look through this data, just like my cars example, the word canoe does not necessarily appear in the results that I'm getting back. In fact, this one says for this St. Croix in Wisconsin, grab your paddle and go on an adventure. And there's nowhere here, it talks about paddling and fishing, but there's nowhere here that you see the word canoe. So it's a very powerful capability that we've got here. Now, so I've already shown you ad nauseum how we can query with words. Let's try looking at an image. So I'm going to actually query some images though, using a word. So I'm going to use my same Canoe version. Let's put in Canoe. And when I query, it's pulled up these entries. Now, I'm showing you this first as it would look in SQL. Let me double click on that, and there you go. So it's pulled up a picture of a canoe. Another one here, someone doing a handstand in a canoe. So we're able to use this ClipVit-based Patch 32 multimodal embedding model and perform a sentence search. So it's extremely powerful what we're able to do here. I can also go the other way, and I can say, look, I've got an image. Why don't I search using an image? So I'm taking a picture that's provided and performing a search of the Oracle database. Oh, and someone mentioned, doesn't it mean it's exact? I can answer that one. So in this example, and I'll get to indexing in a moment, but in this example, I am in fact doing an exact match, but I'm doing the 10 closest exact match, if so to speak. I'll talk about approximate nearest neighbor in section 3, I believe. So yeah, so here I'm going to run a query, but because I'm running through a SQL session, I don't have the ability to upload an image to show you. But what I'm going to do instead is I'm going to run through this little query, and I'm going to provide it with a URL, and that URL points to an image, and I'm going to search on that image that's located at that URL. So the URL I'm using in this particular case, if I jump to my browser, this should look familiar. I'm at AI Camp, and I'm looking at the previous events that have taken place. And I'm going to use this image here of New York as my example. So just so that you can, in fact, I can copy a clean link and run it right now, just so that you believe me. There is the image. Oh no, that's not right. I need the actual image itself. So I'll leave it as that, but it's that image of the Statue of Liberty. So now that I've got that, when I run my query, give it a little moment, it took that image that I provided, and you can already see Statue of Liberty, sailboats against Lower Manhattan. That may not be the Statue of Liberty, but we'll have a look in a moment. Liberty Island, Liberty Island. So it's pulled up based on passing a simple image. It's been able to do a similarity search on what I've presented. So here's the first one. I do not see the Statue of Liberty, but hey, it is New York, so I'm pretty thrilled with that one. Did I put this one up? Yeah, so that was the very first one, the closest match, and yes, we can see that's the Statue of Liberty. And what's even interesting here is the statue. We've got a side profile. If you look at the one from the website, oh no, it's a side profile as well. Interesting. We could also look at a different one here, sailboats. That's the one we saw before. We could look at Statue of Liberty on Liberty Island. And there you go. There's one that's facing us. So very, very powerful stuff. I hope you agree with that. So let's, in the interest of time, let's get back to my presentation and show you some other demonstrations. And by the way, for those of you who joined late, I am including my GitHub repo for you to download these scripts and experiment yourself at the end of the session. So let's have a look at RAG. So you're probably all aware of RAG, and if not, I'll give you a quick explanation of what RAG is. So we're all familiar with ChatGPT and Grok and Gemini and all these large language models, and we can understand the benefits that it brings to the table, right, in terms of being able to query and ask questions to solve business problems. The issue that we have with large language models is, first of all, they're trained at a particular epoch or a particular point in time, and it means that when you perform a query against one of these large language models, often the data, sorry, my phone keeps chirping, often the data may be dated. Also, they're prone to hallucinations, and they may give you an incorrect result. So what we're able to do with the Oracle engine is we're able to provide something called retrieval augmented generation, where we pass business information and we use that to build our prompt to query a large language model. So in this example, we have a person who's an end user at a company, and they want to ask a very specific question. Why does my laptop keep rebooting? Now, I challenge any of you to go into your favorite interface, whether it's Claude or ChatGPT or Grok, and say, why does my laptop keep rebooting? And you'll get any number of answers. You may be lucky and get the correct answer, but it's pretty much a random event. So what we're doing here with RAG, retrieval augmented generation, is we take that question, we vectorize it, right? We take that string of information, we pass it into a vector, and then that
Got
gets...
your screen.
Yep. Okay.
Yeah.
Thank you.
Sure.
Yeah. And yeah, when I'm in presentation mode, I can't see that I've lost my screen sharing. So thank you, Marcus. All right. There we go. Cool. So once we have our sentence or our question vectorized, we can now do one of those similarity searches, if you wish, against our database. And then we're able to do a query against our database, performing that similarity search operation. And not only can we find out about that user, what laptop have they been provided with from the company, what's the version it's at, what's the operating system. We can also look at perhaps support tickets and IT tickets that have been filed for similar problems with other people within the organization. We take that information, and I lost my screen again. I saw that one happen. And I sincerely appreciate you all being patient with this. So we take that information that's been generated and we build a prompt to ask the LLM or the GenAI agent to answer or to ask our question to. So it has a more intelligent understanding of the question we're asking, and then it's able to respond with a much more intelligent answer. Yes, the issue is firmware controlling the fan. Apply this particular OS update because it knows they're at OS, say, 39, update 39 or whatever. So RAG is this whole cycle of being able to engineer the prompt, if you wish, and provide it pertinent information. Now, a couple of things here. First of all, this can happen in a completely secure manner. So everything we're doing can happen within the guardrails of your own business, and the information that we're passing over the fence is not necessarily public information. We also support LangChain and other approaches to providing this communication between your database and the LLM, so we can enforce things such as PII or other forms of security. Now, this is one way of solving it. The other approach that we're also supporting is Langflow and agentic workloads as well, for more than one-shot answering of problems. But what I'm trying to do is show you the building blocks and show you the sample code so that you can get up and running and build things upon this fairly efficiently. So under the covers, the demo I'm going to show you is in fact going to perform these steps. I take a document. It could be a PDF document in my case. It could be a Word document. It could be anything. And using the DBMS vector package, I convert that document to text. I then take that text and I convert it to chunks. So the chunks have to be smaller pieces of text that provide context or can fit within the bounds, if you wish, of my vector. Not only does it create these smaller pieces or these chunks, we also tokenize it and provide mappings. And we give you a lot of control. And I'm just showing you a simple way of doing this, but you could say, hey, I want this to be chunked based on paragraphs or sentences or numbers of words. I could set overlaps. So one sentence, when I create a chunk, the first few words will be the last few words of the neighboring chunk. So it provides the context to associate and provide similarity between these chunks. Once I've created these chunks, I then embed them. And then when I go to perform a query, I go the reverse, right? So let's have a look at this in action. And I will jump to my window here. And in this case, I got to make sure I'm connected to my database. I'm running against the same database I used for my on my Python server. So let's go ahead and make sure I'm connected to my system. And I want my always free system, which is somewhere here. Oh, National Park. Actually, no, not National Parks. All right, let me reconnect. I will disconnect from there. And I will now reconnect when I run that, and I'll make sure I connect to a different database. I have another one here. There it is. Nope, it's not my Docker one. Sorry, I'm getting mixed up here because of my. Where is it? It's DB236. I know it's here. There it is. Perfect. All right. Sorry about that. Am I connected? It's taken a little while. Let's run that again. All right. So I'm on my DB236 database. In this situation, I'm going to go ahead and I'm going to drop my tables just to clean everything up. I'm dropping the tables, and these tables are, as it suggests, one is going to store the tables that I'm loading, the books that I'm loading, and the other is a storage to put my vector objects. I'm going to go ahead and drop those objects. Drop my trigger first, and now I need to drop the function first, which is being called by the trigger. Oh, good, that's been removed, and then I can drop my tables. I'll drop that one, and you see errors. That's all good. Now, I could have also introduced a new database 23 AI feature called drop table if it exists. And what you'll see when I run that is if the table doesn't exist, it's not going to give me that ugly error message. So you get this nice clean message. So now that I've done that, let me just clean my screen up for running these queries. I'm going to create a table called My Books. And I'm going to create one called vector store. And this is the one where I'm actually going to store the vectors. Now, my books, I'm taking in my books that I'm loading, 2 of them, and I'm converting them. You've got the file name, the size, and I'm just storing it as a blob, right? I'm storing this PDF as a blob. And then I'm taking that blob object for that book, and I'm creating a vector for this content that's in there. So that's what I'm going to do. I'm going to use OpenAI for my large language model in this particular case. I've already set up this connection, and this is allowing me to connect through this port range I'm running in Oracle's cloud. So it's opening that port for me to communicate directly with OpenAI. And then I provide a token, and you would have your own token there. That's not my token. It's just an indicator for me to know which one I'm using. And now that I've got that, I'm going to go ahead and run just a simple query against my large language model to show you. And I see I lost my connection. So I'm just going to show you that I can communicate with this large language model from my database. So that's all I'm doing here. And I lost my connection twice in a row. Gosh. It would be nice when we publish this video if we could drop all those out, but I know that would be really difficult. So here I'm going to just verify that I can ask a question of my large language model from the Oracle database using these packages. So I'm using DBMS chain util to generate to text a question that I'm sending. So when I run that, I'm asking, what is RAG, using my OpenAI credential. And here you go. So it's told me RAG can refer to several different concepts. And this is going directly against that OpenAI large language model, right? And what I'm going to do here is I'm taking my directory. I showed you my directory before in my previous example for national parks. And I'm going to take my books and load them into my database. So I've got 2 books here. I've got one, which is the 23 AI release notes, and I've got the database free installation guide for Linux. So I'm going to insert those 2 rows, and I've committed my change, and I can query my books table, and you'll see there's a ton of rows there. Well, actually, there's only 2. It's the vector one that will have a ton of rows. So you can see I've created these 2 entries for both my books that I've loaded, and you can see they're blobs. Now I'm going to run the magic, and in this case, I'm going to insert into my vector store. I'm going to take, I'm calling all those DBMS packages, right, that I showed you in the slide that is right here, DBMS vector util to text, util to chunks, and util to embed, and I'm calling it all from one step or one package. So I'm loading into the My Books table, I'm converting to embeddings, and those embeddings, if you go backwards, the last thing I'm doing is the embedding, and the embedding is of the chunks, which is there, and the chunks is to text. So I'm taking, the first step is to take my content, convert it to text, then convert it to a chunk, and then convert it to an embedding. And I'm giving it some rules. I'm saying, hey, in this case, I'm using words. I want a maximum of 200 words. I'm splitting it in sentences, and I can normalize it, etc. And I'm also telling it the embedding model I want to use when I break this into these smaller pieces. Now, a couple of things. The parameters that I use here in terms of the temperature or the different controls that I could apply is going to differ from one embedding model to another, or one large language model to another. For OpenAI, these are the options I have. So let me go ahead and insert those rows from from this table, and it's going to actually go ahead and load them. And it is running. I can see the little thing spinning here. And this is doing a fair bit of work, right? These books are not small, and it resulted in 123 rows being inserted. So if we look at the data we've just inserted, you can see here's the chunks. This is from document 1. Remember, I've got two documents in there, document 1 and document 2. And here's the strings of information. So I can now ask a question of that data using the large language model and the data that I've vectorized within my table. So I'm going to say, with this query vector, I'm going to look for a particular search string. So it's one, and say ARM. I'm interested in what there might be specific to ARM processors. And here we go. I wanted the approximate. So you'll notice I used the word approximate. I'll talk more about what that means in a moment, but it's showing me the first 4 rows. So yeah, it's got ARM architecture there. And if we scroll through, we'll see there's probably other occurrences. Now, remember, this is a similarity search, so it doesn't necessarily have to be an exact match, right? Here's the other reference to ARM. So you get the gist of it. Now, I could also say, hey, I want to just display the source document. So another way of performing that same query, and I will keep it with ARM as my search string. And here it's provided me the string, it's provided me the document, and it's provided me the chunk ID. So perhaps I want to tie this to an application. One of my colleagues presented Apex a few weeks ago. You could tie this to your Apex application. Now, I'm not going to go through this, but it's in my code. I can create a package so that this package gets called to perform those operations that does the embedding and everything. And I can build a trigger to, whenever I load an object into that table, it will fire this trigger, which will perform this operation to go ahead and chunk it down and vectorize it and store that information in my table. So it's possible to automate all of this, and I've got the code there for you to play with if that's something you want to experiment with. And I do have one last example. Oh, I've shown you how to call the LLM from within the database. Here's another example, a smaller set of code. And in this case, I'm going to ask it the question, what is AI Camp? Let's see how well it scores on that one. So this is yet another way to skin the same cat, right? Run this same operation. And here you go. So it says AI Camp is typically a program or initiative that focuses on educating participants about artificial intelligence. And I see my screen died again. So this is information that OpenAI is providing the answer to. It's not something that I've stored internally. So hopefully you're getting the gist of what we're able to accomplish with this combination of very powerful tools. And I'm going to show you MCP server after this as well. I know that was a topic that was covered last week, but I'll show you a quick demo of that as well. So let's jump back to my presentation because we've got some other topics to get through. I showed you the RAG demo. The next topic is indexing. So someone did ask a question earlier, and they said that I'm basically doing an exact search, and that is absolutely correct. When we create indexes, so not only has Oracle provided the ability to store vectors in the Oracle database, we store them as a column in a table so you can join with other tables. We also provide you with the ability to create the embeddings inside the database or call them from outside the database. The third piece that we've added is the ability to create vector style indexes on top of your data. So these are very different to traditional Oracle B tree or bitmap indexes. These are vector centric indexes, right? And before I show you my demo, let me just explain this a bit more. We have three fundamental types of indexes that we support out of the box, and I think I'm running out of time. We have HNSW indexes, and we have partitioned indexes as well. And the HNSW indexes are graph style indexes, and the partition indexes are partition-based indexes. They're IVF flat, and they provide acceleration of querying your vectors, and they are an approximate nearest neighbor solution. And Tara, I can't recall, I'm probably run out of time. So let me just show you what that looks like without running it. I have a very large table that I would use for this demo. But yeah, Tara, if you need to speak up and stop me and open the line for questions, I'm happy to change course.
Yeah, we got about 7 minutes left, so I think you can keep going. But yeah, if anyone has any questions for us, I know we've gotten several really great questions so far, so keep dropping them in the chat and we'll keep answering them as we continue. So.
Oh, fantastic. So if that's the case, what I will do, rather than show you how they're created, one of the things I do want to point out, if this is something that you're genuinely interested in, have a look at the GitHub repo, because I have an example where I load a very large table and I gather statistics and I show you the execution plan, how it changes, how it evolves when you run a query with an inverted file flat index or an HNSW index versus the full table scan that you would do in an exact K query. The other one I want to show you, or I'll mention really quickly, is something we have called some data summarization. So we have the ability to take a large chunk of data and summarize it into a paragraph or two, or however small you wish to make it. And in this case, we follow the same model. I'm using OpenAI. You could use Gemini, whatever you want. And we allow you to take this string, and I'm just using a sample text to show you as a paragraph, so you kind of understand the plumbing. When I run that query, it will give me an output. Now, we introduced, I need to connect to my database. We introduced this as a means to actually allow you we introduced this as a mechanism to allow you to take a document and shrink it down for generating vectors and to perform those RAG style operations. But it can also be used for other purposes, right? If you have an application where you want to summarize what's there. And here I've taken a really complex string where I've got a medical procedure, and I'm having it summarize it for me in a brief version. So here it's giving me, sorry, ignore those error messages from before. Here I run a clean version. It's telling you what the procedure involves, right? Now, there are other ways you can have this presented to you. In my VS Code plugin, it's not doing my wraparound properly, so I apologize for that. But there's other ways to do this. I could take it from, in my sample code here, you could take it from a blob in your table and perform that operation. Now, one last thing I want to show, and I'll wrap it up there, is I do want to show you something that I have in my presentation deck, which is using MCP server to solve a lot of these problems. So I talked about data summarization and indexes, and I want to really quickly talk about MCP server. Now, I know this was a topic that was explained before, but I'll show you really quickly. You install SQL CL 25.2. Once you're connected in, you run the following string with your password, and this creates your MCP service. Once you've got that, you go into your favorite engine like Claude, and you can connect to that SQL CL connection, that MCP server, and you can start asking it questions of your Oracle database. We also support, once that's done, you can plug in Klein, and I've been able to do that with my Oracle database as well. In VS Code, you plug in Klein or Cursor or Roux or some other tool, and you connect to that MCP server. And I, in fact, did this exact thing. And then I went ahead and I used my national parks example, and I built a front end to run queries against my national park app. using Klein to build the application, using my vectors to do a similarity search and to present my output. And I know we're going to Q&A now, so if you want to ask any questions while I queue up this demo, please feel free to fire away. Any questions?
Let's see. I know Marcus was answering several questions. I don't know, Marcus, are there any that we should elaborate on live? Question about, are vector embeddings good enough for video data?
Yes, absolutely. So we're working, we have a couple of reference customers. The most famous one that I've worked with, or for me, is a company called Dewey Vision. They're using Oracle's database for doing the editing for films and commercials and all types of video footage. Because at the end of the day, a video footage consists of frames or photos. And Dewey Vision is being used for, you can use their tool to query and say, I'm looking for a scene with these characters with the sunset in the background, and it will find you the film footage. And they have some pretty big name customers who are using their product for that. Okay, so really quickly, I've fired up my application that I wrote using Klein. I basically wrote that paragraph of text, and this is the application it wrote for me. I didn't choose these colors. I didn't choose these images or icons. This was all generated using MCP Server. So it's a really powerful tool, and it's using the Oracle database. It's using that same information that I went in and embedded or created vectors for. So definitely take a look at that and play with it. I'm sorry I ran out of time, but this is as much coding as I used. It's the truest sense of vibe coding. So I'll end by putting my last slide up. Just
Sure.
yes.
There's another question from Fred. One of the main workflows with machine learning DL is ETL processing overhead. Does Oracle provide helpful starter packages and simple to use intuitive tools for this tailored to specific industry verticals? The idea is to overcome the blank sheet problem for putting together the ingestion portion of the ML/DL pipeline. This would be helpful.
Yeah, that's a really good question. So keep in mind. So let me just preface this by saying that what I've talked about today is how we can solve your problems with vector search and vectors in your Oracle database. But Oracle has a huge portfolio of AI solutions, right? We have agents, we have other types of services that you can call either pre-configured or you can run yourself. And that aspect of what we do is ELT, not ETL. And we have a whole machine learning canvas, if you wish, that's Apache Zeppelin based for calling various models or using models that we have to assist with building those types or solving those types of problems. One of the things we also support in our cloud, if you're interested, we have GPUs available to you. And why I mention that is those same machine learning notebooks that we support these different embedding models or tools to solve these problems. There's a drop down where you say, hey, I want to throw a GPU at this, and you pull the drop down and it will run your process using a GPU to speed it up. Everything I've shown you today does not involve GPUs, does not require GPUs. And we're using the horsepower of the Oracle database engine to solve a lot of those problems. So I hope I answered that question. Keep in mind the Oracle database, the Oracle ecosystem includes all of our Fusion apps and our various off-the-shelf or cloud-hosted application solutions. And because of that, we have something called OIC, integration cloud, which provides plumbing for doing that same ELT style operation as well. And it's integrated with what I showed.
Yeah. Sure, another question. What MCP server do you recommend that works with open source models like from Hugging Face?
So the MCP server I'm using in all of my demos is Oracle's MCP server. It's completely free to use, and you simply install SQL CL 25.2, and it's there. It's built in. And then I'm running Claude as my backend agent or engine to call it. And it's extremely simple to configure. It took me 30 seconds. I installed one from, oh, I see we've run out of time. Sorry. Yeah, thank you all for staying through to the end. And I apologize sincerely for losing my connectivity continuously.
Okay. I think there was one more question was about the free certification, the race to certification.
Oh, yeah.
What will it include pertaining to what we talked about today?
Yeah, so great question. Thank you for asking, relaying that one, Tara. So this is the one here, AI vector search. It will talk about the embedding models, how to call them, the Onyx libraries, other approaches to loading those embedding models. And keep in mind, when we provide this certification, we don't just force you to do an exam. We have a series of classes that you can attend that are online, and that's what you can run those. I believe they're free to use. I don't know because I'm an Oracle employee. But yeah, you go in there, there's like 3 or 4 hours of training, and there's quizzes along the way. And at the end of those quizzes, you can actually take the certification exams.
Yeah. And then there's a couple other free resources to get started that I'm going to drop again too. In chat. There we go. And we'll be sending you the slides as well. And I dropped that link too, but we'll have this full deck with all the links in it as well, along with the recording.
Yep. Is there a number of times? I'm not sure. I think it's just before the cutoff time. I don't know the answer to that. I don't want to give you misinformation. I don't want to hallucinate. All righty. Well, thank you so much, everyone. And thank you, Marcus. You've been immensely helpful.
Thanks a lot, yeah. You guys. Sure. Okay.